This is a brief overview of the RAG Group's informative presentation entitled Human Error in Safety Interventions, and the research that grounds it. The systemic model, as we will refer to it, is a fruitful model for understanding why incidents happen and what has been done to reduce the likelihood of future incidents. The grounding assumption of this model is that incidents occur in hazardous environments. To keep these hazardous environments from producing incidents, we have engineered in mechanical safeguards like pressure valves, process automation, and simple machine guards. But there are inevitable gaps in these mechanical safeguards. An unanticipated surge in pressure beyond the capacity of a blowout preventer, and the system fails. An incident occurs. So we build in procedural safeguards as well. Safe operating procedures for those people who have to work in environments that can't be made perfectly and invariably safe through engineering. Few, if any, procedures are flawless and cover every possible circumstance within complex operations, and so we see that there are also gaps in procedural safeguards. This is demonstrated by the frequent, albeit necessary, revision of safe operating procedures across industries. From one situation to the next, gaps in the mechanical and procedural safeguards will come into play, and when they align, the system fails to prevent hazards from resulting in an incident. Fortunately, we have people in our systems as well. Unlike rigid mechanical and procedural safeguards, humans are capable of evaluating their environments rapidly, repeatedly, and creatively to anticipate and respond to hazards, keeping them from resulting in incidents. But we know all too well that there are gaps in humans' performance. And, as before, when these gaps align in a given situation, the system fails and an incident results. This leads us to ask, why do humans fail to prevent incidents? Or worse, why do they do things that create new gaps in the mechanical and procedural safeguards? Why do people skip pre-job hazard analyses, remove guards, or fail to wear personal protective equipment? In short, why do people do what they do? When it comes to safety, there are a few things about human behavior that are vital but often overlooked. First, people do what they do in complex environments. As such, they're impacted by a multitude of factors in their environments. Second, people do not want to get hurt. With this in mind, when we observe an unsafe behavior, we're driven to understand why. What would lead this person to do something that could hurt himself or his coworkers? From outside of the situation, it looks simple. It's human error. But when you put yourself in the situation, where there are a multitude of factors influencing people's actions, it rarely is simple. An initial look at why people do what they do leads us to think about the person's motivation and ability. The employee doesn't want to make the extra effort to follow safe operating procedures, that would be motivation. Or he doesn't know the safe operating procedures, that's ability. This model of human behavior only gets us so far, though, because there are other forceful elements in people's work environments. Most people work with other people, and those people can motivate, demotivate, enable, or hinder safe behavior. A supervisor presses his crew to get a job done ahead of schedule, motivating employees to sidestep time-consuming safe operating procedures. Or an employee's coworkers refuse to help her lift a tool that should be team-lifted, undermining her ability to lift safely. The organization, which includes, among other things, the company's policies and procedures, incentive programs, and employee appraisals, can also impact both motivation and ability. We have seen numerous companies unintentionally motivate unsafe behavior by promising huge bonuses for completing jobs ahead of schedule. And we have seen companies that so rigidly require their employees to follow certain operating procedures that, when unexpected conditions arose on the job, employees stuck to procedure instead of doing what was safe. The physical environments that employees work in, which includes both natural and man-made elements, can also have an impact on motivation and ability. When it's 100 degrees Fahrenheit outside, an employee is unmotivated to wear fire-retardant clothing that holds in body heat. In human workplaces, safety glasses can fog, making it difficult for employees to actually see trip hazards, pinch points, warning indicators, and other environmental hazards. For whatever reason, whether it be motivation or ability, personal, social, organizational, or environmental, unsafe human behavior can result in an incident unless it's stopped. This is where others come in. When a person acts unsafely, the people around are in a position to prevent that behavior from resulting in an incident, and they do so by intervening. An intervention occurs when an unsafe act is being observed by another person. And interventions have three parts: stopping the unsafe act, diagnosing the reasons for that unsafe act, and then redirecting the behavior. To better understand safety interventions and how frequently and effectively they occur in the workplace, the RAG Group conducted a cross-industry study, which surveyed over 2,600 employees in 9 countries. While the results of this survey are substantial and far-reaching, we will pull in only a few points here, which pertain to the 3 elements of safety intervention: stopping, diagnosing, and redirecting. The purpose of stopping unsafe acts is straightforward. It is to stop unsafe acts from resulting in incidents. In our study, respondents said that, on average, they do not speak up 38% of the time that they observe unsafe behavior. Concerning the diagnosis that occurs during a safety intervention, which is the point at which the intervener finds out the real reason or reasons behind the unsafe behavior, our study revealed a prevalent problem. 83% of respondents believe that others act unsafely because they don't want to make the extra effort. In other words, other people lack personal motivation. But when asked why they themselves act unsafely, only 4% of respondents said it's because they don't want to make the extra effort. When people see someone acting unsafely, they usually chalk it up to personal motivation, but we know that human behavior is far more complex. Personal motivation isn't even half of the equation. Diagnosing unsafe behavior means understanding that behavior in its context, its personal, social, organizational, and environmental context. The third element of safety intervention, redirection, is aimed at creating sustainable behavior change. It's the part that ensures that when the intervener turns his or her back, the other person doesn't go right back to the same unsafe behavior. Survey respondents said that, on average, 1 out of every 5 interventions does not result in immediate behavior change, and 1 out of every 2 interventions does not result in long-term behavior change. Spurred by the results of this study and our understanding of the profoundly important role of human behavior in accident prevention, the RAG Group conducted a second study to identify the most important intervention conversations, those conversations that have the greatest impact on safety. After identifying 12 critical intervention conversations, we used best practice research to develop a competency skill matrix. This matrix directs the effort to make employees competent at conducting safety interventions. That is to say, competent at stopping unsafe behavior, diagnosing it, and redirecting it. What we have found in putting these best practices to work is that effective interventions lower total recordable incident rates, lost time accidents, near misses, and interestingly also positively impact employee retention, morale, and productivity. Effective interventions result in safer behavior because they eliminate and shrink the gaps in human behavior, preventing hazards from resulting in incidents. But effective interventions also result in safer systems because, by diagnosing the reasons behind unsafe behavior, previously unnoticed gaps in mechanical and procedural systems are revealed, allowing organizations to fill those gaps, and as a result, significantly reduce the likelihood of an overall safety system failure. To put it all plainly, the more frequently and effectively safety interventions occur, the lower the chance of an incident.